Okay, so we're looking at the section 7-2 test review problems. Notice it says the problems below are with 3 bonus homework points if turned in by Wednesday for 8. Now, I ended up deciding to change that. I apologize. I believe I'm going, well, you know what? I didn't change it on here, so I guess I'll just leave it. And again, these are due on the day of the Chapter 7 and 8 test, which has stayed to be Wednesday for 8. Okay, so our problem is a New York Times poll on women's issues interviewed 1,025 women, randomly selected. Okay, so I'm instantly thinking that is important. That's going to help me meet my condition later. I also want that number, it's going to be my sample size, from the United States. That also tells me my population, women from the United States. The poll found that 47% said they do not get enough time for themselves. 47%. I'm thinking that's going to be my sample proportion, but I want to read what I'm trying to estimate before I decide for sure that's my sample proportion. So it says construct and interpret a 90% confidence interval. There's my confidence level. For the proportion of women, they're telling me the parameter here, proportion of women in the United States who do not feel that they get enough time for themselves. So when I'm looking back, let's go all the way back to the last page that I was looking at my sentence for interpreting the confidence interval. I can already know most of what I'm going to fill in. We are 90% confident that the interval from blank to blank, I don't know that yet, haven't calculated my interval, but it's going to capture, or I'm hoping it's going to capture the true, and this is where I'm going to fill in, the true proportion of women in the United States who do not feel that they get enough time for themselves. That's where I get my parameter with its context from. Okay, so now that we've pointed that out, let's go ahead and follow our 4-step process. I've got my, these are my IS number 14 notes next to me. Part 4 walks through the 4-step process. So I'm going to look at the printed part to remind myself what to write. So I start out with the state. I state the parameter you want to estimate and the confidence level. Now, the template that I gave you goes ahead and writes this parameter blank, confidence level blank. That's not going to be given to you on the test, so you don't have to write parameter blank. You can say, we want to estimate P equal to whatever. So we're going to do here. So we're going to start with the state step. Please do label your steps. We want to estimate P equal to, and I'm going to fill this in, the true proportion of women in the United States who do not feel that they get enough time for themselves. Whew. Okay, it's kind of a long context, but that's okay. And I'm going to say at what level, right? So at the 90, or I don't need to say the, at, I could say at, but I also like to say with. So I'm going to say with 90% confidence. There we go. Okay, so I stated my parameter in context. Oof, it's kind of long. And my confidence level, 90%. Okay, so now my next step is to plan. So again, it says to name of procedure and check the conditions. I don't have to write those 2 things down. I just have to write what the name of the procedure is. And of course, it is a 1 sample Z interval for P. So I'm labeling this the plan step. I'm going to do a 1 sample because I just have 1 sample. I'm using the normal curve, so it's a Z, and I'm doing an interval, not a test. So Z interval for the proportion I want to estimate is the parameter I want to estimate is proportion, so for P. All right, now I need to check the conditions. So the first condition is whether or not I have a random sample. And my problem statement says they were randomly selected. 1,025 women who were randomly selected. Just quoting from the problem. Okay, so that condition is met. Number 2 is the 10% condition. So my sample size is 1,025, Is that less than 1/10 of all US women? Remember, my population is women in the US. So let's see, 10 times 1,025 would be, let's see, 10,250, right? Just put a 0 on the end, 10,250. 10,250 is definitely less than the population of US women. So that condition is met as well. And then I have to check the normal condition. For proportions, remember, I use the large counts to check the normal condition. So I'm gonna write that down. Large counts. So I check n times p hat because I don't know what p is. So n times p hat, let's see. All right, I know that n is 1,025, but going back up to my problem here, it said the poll found that 47% said they do not get enough time for themselves. That is the estimate of the proportion I want. So my p hat is not 47%, but 47% converted to a decimal, 0.47. Okay, so that's what I'm multiplying by here. N times p hat is 1,025 times 0.47. Oh, let's calculate what that is. And of course, I forgot my calculator. Oh no. Okay, I'm gonna go get my calculator real quick. Sorry, guys. I will be right back. All right, so 47% of 1,025. Let's see what that is. 1,025 times 0.47. 481.75. These are people we're talking about, so we're going to round appropriately to a whole number. So this should be 482. 482, which of course is greater than or equal to 5. Then we have to check n times q hat, which I could go ahead and multiply 1,000. Well, first of all, figure out what q hat is. 1 minus 0.47 is 0.53. Multiply that times the sample size. That's one way to figure it out. I'm going to round appropriately to 543. Or if 482 said they feel they do not get enough time, then 1,025 minus 482 must be the number who feel like they do get enough time, 543. Either way is fine for calculating this. 543 is greater than or equal to 5. Okay, so that condition is met. So now that our conditions are met, we are ready to move on to the do step. So remember, there are 4 parts to the do step: general formula, specific formula, plug in numbers, give your answer. So let's label this do. Our general formula for a confidence interval is a point estimate, or is the point estimate, plus or minus the margin of error. Okay, our specific formula, remember, is p hat plus or minus c star times the square root of p hat times q hat divided by n. Let's fill that in. This is equal to p hat plus or minus z star, square root of p hat times q hat divided by n. Okay, so I know p hat, which means I know q hat, and I know n. The only thing I don't know right now is z star. So I'm trying to find a 90% confidence interval. So let's see. I can look at table A2. This is the negative side. We want the positive side. So come down here. There's my common critical values. For a confidence level of 0.9, which is 90%, I use a critical value of 1.645. Okay, so 1.645 it is. I'm gonna go ahead and write that out to the side here. So z star equals 1.645. There are a number of ways that we could have found that without looking it up, but since it's listed on table A2, I'm fine with just writing down what it is. Okay, so let's fill in. We have p hat is 0.47 plus or minus z star, which is 1.645, times the square root of that 0.47 times 0.53, which is q hat, divided by n, which is 1,025. Okay, so some of you go ahead and work out this right side first. I'm not saying you're wrong, but I'm saying you get rounding error a lot. You should type all of this in at one time. As you go across, don't write plus or minus. Start with the minus, and then the second time you do this, you do the plus. So let's type it all into our calculator. we have 0.47 minus, like I said, use minus first, 1.645 times second square root 0.47 times 0.53 divided by 1025. Okay, now I'm ready to hit enter. I get 0.444. 3 decimal places is great. And then I'm going to get my second one by going through all of this, except this time I'm using plus. So I can just go up and select it, hit enter, and now I'm ready to scan over to change that minus sign to a plus sign. And I get my upper bound. Let's see, I want 3 decimal places, so it'll be 0.496 if I round appropriately. Okay, so this is equal to 0.444 to 0.496. There we go. So our final step is to conclude, and this is where we use that sentence for interpreting confidence intervals. So we say, we are, again, this is what I wrote at the bottom of the formula sheet. We're using that sentence. Just leave it there, actually. We are, our confidence level was 90%, so 90% confident that the interval from, okay, we fill in our interval limits, 0.444 to 0.496. So I could convert this to percentages if I wanted to think about it that way. So from 44.4% to 49.6%, right? 47% is between those. Captures the true mean. Oh, gosh. That is a pretty common mistake to just go ahead and write mean. Remember, this is a proportion. So I'm going to go back up and fill in my parameter. So in context, of course. So all of this, the true proportion of women, blah, blah, blah. True proportion of women in the U.S., let's see, what was it? Who do not feel that they get enough time for themselves. Who do not feel that they get enough time for themselves. There we go, done. Okay, so that is a confidence interval for a proportion. So let's flip it on over to the back. There was kind of more to this section. Number 2 says, Mrs. Bacula wants to conduct a poll to estimate with 95% confidence the proportion of students in her school who have jobs in the evenings or on weekends. So I'm already thinking, all right, 95% is important. That's my confidence level. And here's my parameter, the proportion of students in her school who have jobs in the evenings or on weekends. So then the question though says, how large a random sample is required to obtain a margin of error of at most 0.05? That's important. Margin of error of at most 0.05 with that 95% confidence, right? Matches what I originally said. So this question is different than the previous one. Obviously it doesn't say construct an interval. It wants to know how large a random sample we need. How big of a sample size do we need? Okay, so in order to do that, there are a number of different ways. We can remember the formula for margin of error. We could have written in E is equal to here. E is equal to Z star times the square root of P hat times Q hat divided by N. I know the margin of error that I want. I can figure out the critical value corresponding to 95%. I'm trying to find N, so really that just leaves P hat and Q hat. Now, in this instance, it did not give me a previous idea of what that sample proportion should be. So remember, the conservative guess for P hat is 0.5. Okay, which means Q hat is 0.5. That's the most middle ground we can have for a proportion. It'll give us a larger sample size than we possibly need. Say the true sample proportion is going to be 0.3, right? Our sample size will be a little bit larger than we actually need, but we'd rather be larger than not big enough. So this is conservative to go with 0.5. Okay, so then, like I said, we know the margin of error that we want. We have 0.05. That's the largest margin of error we want to have, so we'll write that down. And then we have a 95% confidence level, which will tell us what critical value we need. Some of you probably already have this memorized for 95% because we use it so often, but we can look at that table A2 again and come back. Again, we're on the positive side. Come down here to the common critical values. For 0.95, we use 1.96. Take this out as a later. Okay. So let's go ahead and write that down. Z star is 1.96. So we could fill in to this formula and then solve for n, but your book goes ahead and gives you the solved version, right? If they, rearrange that literal equation to solve for n, they tell you what that equation would be. So let's go ahead and write that down. It is that n is equal to z star squared times p hat times q hat divided by e squared. And then it points out that if you don't have a guess for what p hat are, if you're not told any information previously, to again use 0.5 for p hat, 0.5 times 0.5, p hat times q hat is going to give 0.25. So really what your book gives is z star squared times 0.25 divided by e squared. But again, that's just our guess of 0.5, the conservative one, times itself here. Okay, so let's fill in what z star and e are. So we have 1.96 squared times 0.25 divided by e squared, which is 0.05 squared. Okay, we plug that in to get our sample size. So we have here 1.96 squared times 0.25 divided by 0.05 squared. Okay, I think that's everything. Hit enter, I get 384.16. So I obviously can't have 0.16 of a person, and it's tempting to round down because obviously 0.1 is less than 0.5, but remember we want our sample size to be large enough, right? We can't undervalue our sample size. So with sample size estimations, we always round up. So this 384.16 is what we technically get, but we round up to 385. And let's go ahead and write what these are. These would be 385 students we would need to survey. 385 students. Okay, that's answer number 2. So then it says in part B, based on your answer to part A, how big does her school have to be for the 95% confidence interval to be accurate? And explain. Okay, so let's think about those conditions we have to check for our confidence intervals to be accurate. We have to have a random sample, 10% has to be met, and a normal condition. So the normal condition does not depend on that sample size. Well, I guess the sample size does depend on it. But if we have 385, there's a really good chance that those are going to be greater than or equal to 5. The one that does depend on n really is this 10% condition. Remember, n has to be less than 1/10 of the population size. So if she's at a small school, say a school of 1,000 students, 385 is not less than 10% for 1,000 student population. So let's figure out what it does have to be. The 10% condition says that n has to be less than 1/10 of the population. I'm going to say of the school. So we have n equal to 385. We want that to be less than 1/10 of the population of the school. So if we multiply both sides by 10, multiply by 10, multiply by 10, that 1/10 cancels out. And let's see, 10 times 385 is 3,850. Must be less than the population. Remember that 1/10 is canceled out of the school. Okay, so in order for that inequality to be true, the population of the school, I could just reverse this, must be more than 3,850. I'm going to reverse it. Write it down. Population of the school must be more than 3,850. Okay, in order for that inequality to be true. Remember, if you switch their sides, you have to flip the inequality sign. All right, so the question was, how big does our school have to be? The school must have more than 3,850 students. Okay, and maybe it says explain, so I'll say in order for the 10% condition to be met. Okay, all right, so these are some possible questions that could come up from section 7-2. You probably will not be asked to do a confidence interval from every section that we have. So you will have to know how to determine whether you're looking at a confidence interval for proportions, a confidence interval for means, or whether you're doing a hypothesis test for proportions or for means. But if the problem is a confidence interval for proportions, this is what you will do. And if you have to determine the sample size for a confidence interval for proportion, this is what you do. All right, in the next video, we will talk about section 7-3.